So now that we have the wheel off the car, we're going to balance the wheel and tire assembly together. We see here the lug circle, but here is the arbor hole, and that's where the collet or cone will reside. We do not want to balance from the front side. If you must, you must, but we would want to balance our cone from the back side of the wheel and tire assembly. The reason why is, from the manufacturer, this part is honed or trued to specification, where the front isn't as tight a tolerance. Steel wheels, aluminum wheels, again, should be balanced from the back side. To locate your collet or cone, simply bring it in and do a fit check. Once I have a visual and a feel, and it passes, I'm going to go with that cone and collet chosen. We can see that this one here worked just fine. If I grab a smaller one, you can see it drops in almost through, not working. A larger one, again, won't fit and does not work as well. These collets are double-sided. Depending on the taper that you need, you will find the fill and the fitment desired. So now I found this collet will work on this wheel, mounting from the backside into the arbor hole. I'm going to slide it onto the shaft, all the way back up against the hub plate there. Of course, grab my wheel and tire assembly and slide it up as well. Once I have it on the shaft, I bring it back, rest it onto the collet, bring my wing nut in position, start it, and then double tap. So now that I've chosen the correct collet for this wheel, I'm going to cone it from the back, as I mentioned earlier. Slide it back all the way against the base plate, bringing the wheel and tire assembly up, putting it up against the collet or cone. Now I take my wing nut, rotate it on a couple spins, and double tap. That will bring it up snug, but you will need to tighten. By pressing on the pedal, it will lock the assembly in position, and now I can give it a final twist, and now it's secure onto the balancer. When we look at the screen, it says Shoreline CC. If I touch the screen, it will say, do you wish to enter manual weight mode? And I hit OK. When it's in manual weight mode, it says it across the top. Where it did say Shoreline before, it now says manual weight selection. I recommend keeping it in automated mode where it says Shoreline CC. Now with the machine in automated mode, I bring my arm in to the lip of the wheel. We can see here before that the weight was tacked on, so I'm going to tack it on again, and I'm going to identify that to the balancer by putting this arm in the same position. Once I've done so, I will tap the pedal. Once I tap, the inner measurement has been set, and where the weight is going to be applied has been set. Let's remove the previous weight before we start. Outside position was selected. Now let's select the inside. Grabbing the arm and sliding it into position and setting it where I wish to put the weight. Again, I press the pedal and the weight selection has been made. Now that we've set everything up, let's go ahead and do a road force balance. Drop the hood in position. The machine will ask if it's set at the correct air pressure. This is important to road force. We want the air pressure set to what the vehicle runs. So we lift the hood back up, grab the air off, find the stem, and connect. The machine will inflate the air pressure or deflate to what your desired setting was. As you can see here, the setting currently is 32 pounds. Once you've done so, it's now ready for road force. Let's drop the hood in position and start our road force balance. Once the balancer is finished calculating the static, dynamic, and the road force variation, the menu comes up showing us what we found. First off, we see the static imbalance is the problem because we've used smart weight. We see it highlighted here. The dynamic or couple imbalance we see is actually pretty good. Our road force variation shown here on the icon, we can see the variation increase is only 12 pounds. When it comes to a passenger assembly, 12 pounds is acceptable. Looking at the screen, we see this part of the tire highlighted in green. This is the road force variation, and this again is showing green is acceptable, but if you want to show or know where the problem lies in the sidewall of the tire, this is the force variation right here. This is the stiffest part of the tire running on the ground. If there had been a problem, that force variation basically means this. The couple imbalance, the static imbalance would pass, but as that tire goes down the road, it's literally hopping down the road and therefore causing the vehicle to shake or shimmy as you drive. As you can see on the screen, no weight is required on the outside flange of the wheel, but weight is required on the inside of the wheel. The weight right now is highlighted in yellow, showing us off center of where we want to put it. If you hit start, the machine will actually rotate the wheel and tire assembly into position and highlight in green, showing us ready to have weight applied. Now that we've rotated the wheel and tire assembly in position by touching start, it's time to apply the weight. By pushing on the pedal, we lock the assembly so it doesn't rotate, and we see the laser showing the 6 o'clock position where the weight will be applied. Since we are using tape weight, I take the tape weight in hand, and now I will take it down and apply it by centering it with that laser. Quarter ounce segments, 8 of them equals 2 ounces. I put the laser and the weight dead center and push down to apply the weight. So now that I've applied the weight, the machine has asked me to do a check spin. I'm going to drop the hood and see what happens. Now that I've done the check spin, the balancer shows that everything is okay. The imbalance is gone, and again, my road force is good. Now that we've done our balance and we had no problems, what would we do if we did have a problem? Let's take a look at that. At this point, it's important to just read the screen. After I press centering check, I'll see information come up telling me what to do. Remove all interfering weights. Place the inner arm against the rim as shown. Press the outer arm button or start when ready to take the readings. Motor will automatically rotate the wheel. I'm going to scan my outer flange and the inside of the outer flange to make sure it's clear of all weight or debris. As we saw earlier, this wheel has no outer lip for the weight to set on, but just give it a quick scan anyways. We've looked at the wheel, we've cleared it of all debris or weight. Now we're going to bring the arm in and rest it right here in the wheel where the bead sets against the wheel. Now we grab the outer arm and bring it down in position right here, setting it against the tire and wheel assembly. Now I'm going to depress this button to start the procedure. But again, on this particular wheel, there is no outer flange for this roller to set. I'm going to start with the button and release it and let it go back into home position, because it's not able to run properly against this wheel and tire assembly to get a correct measurement. But we can see on this side, the arm runs true on the wheel, giving us a correct reading. As we start to take away information though, understand that your readings will not be as accurate. Since I set this outer arm back, my readings would not be as accurate as if I could have applied that to the wheel. But again, because of the wheel's feature, I was not allowed to do that. So now, again, reading the screen, it's telling us position the valve stem at the 12 o'clock and then press the pedal to enter the valve stem position. So as the screen said, rotate the stem to the 12 o'clock position of the spindle. Once that's located, I can either enter the valve stem or tap the pedal. The screen now tells us the next procedure. Loosen and relocate the wheel and adapter from the present position. Place the inner arm against the rim as shown. Press the outer arm button, start when ready to take the readings. So let's go ahead and do so. I break it free, just enough to loosen it. I bring my hand in and I rotate the collet, and now I come back out and retighten. Again, press the pedal to stop the shaft from spinning. So just as we did in the first procedure, when we brought the arm into position and the outer arm into position and press the button, we will do so again. Returning the arm to home because it cannot ride on the outside of the wheel, leaving the inner data set arm on the wheel. It will come to a stop, return it, Again, reading the information that the menu is applying, position the valve stem at the 12 o'clock and press the pedal to enter the valve stem. So rotating it and then entering. Go. So why did we do that? If we brought in wheel after wheel and balanced it improperly with the wrong cone, we would send the car out with a vibration problem. Since we did the balance procedure the first time, put them on the car and drove away and had a problem, came back, let's start with the most simple thing. Are we using the right cone? That's why centering check is important. So earlier, this wheel and tire assembly passed road force. Let's take a look at if we had a problem. By touching road force, a menu pulls up and we're going to take a look at what we call force match. After we hit force match, it will ask us to measure rim runout. We do that by bringing the roller up in position where the tire and the wheel will set. Now that we've set the inside, let's set the out. We take a look here, there's no position for this roller to set on. So we're going to bring it back into home and just press the button. As we can see here on the screen, the road force variation is highlighted here in green on the sidewall. Now highlighted in green on the wheel is the low part in the wheel. By identifying or marking the tire and the wheel, now we can dismount and bring the two positions together, putting the high spot of the tire to the low spot of the wheel, giving it better runout or lower road force variation. To summarize, road force variation is important to find the problem. It is a diagnostic balance. And by finding that problem and bringing the two pieces together, we can take it and drop it below that threshold. Once it's below the threshold, a typical balance, static and dynamic, and road force variation, all matched, will have a smooth riding car.